Exponential functions. Start off with an example. Y equals 2 to the x is an exponential function. And what we can do is we can plot points and then we'll sketch the graph. Okay, so let's put in, I'm going to start sort of in the middle on this chart here and put 1. So when x is 1, we have 2 to the 1 power, so that's just 2. X is 2, we have 2 squared, which is 4. 3, 2 to the third, which is 8. 4, 2 to the fourth, which is 16. As x progresses by 1, what happens to y? Y doubles. This is called exponential growth. And it's actually a really good idea to know some of these powers of 2. Just, sort of memorize those, I think, would be useful. Even though I won't be able to sketch these on a graph. A little bit overkill, maybe. Okay. So why not memorize these? This is a good one to know, is that 2 to the 10th power is around 1,000, 1,024, if you're trying to make calculations in your head. Now, here I'm increasing x each time as I move down the chart. What if I go the other way? I decrease x. As I increase x, y doubles. As we decrease x by 1 each time, increments of 1, we half y. 32, half of that's 16, half of that's 8, half of 8 is 4, half of 4 is 2, half of 2 is 1, half of that's a half, 1/4, 1/8. This is really an explanation of why 2 to the 0 power is 1. Or if I have -1 here, why it makes sense to say that 2 to the -1 power is a half. 2 to the -2 is 1/2 squared, which is 1/4. 2 to the -3 is 1/2 to the third, which is 1/8. Okay, so as x increases by 1, we double. As we decrease by 1, we halve. When we have 0, we get 1. 2 to the 0 is 1. Well, shall I just put them over here, maybe? Let's put the graph here. Could use graph paper. It might be a lot better. Okay, I have 16 lines there. So we start off with, I'm going to write 2 to the 0 is 1. So it's 0, I get 1. At 1, I get 2. At 2, I have 4. 3, 8. 1, 2, 3, 4. And then 4, 16 is already up here. This graph grows really quickly. So one of the things I think about, maybe because I'm getting close to retirement, is I think about how investments, I sort of don't like that, okay. Investments have exponential growth if it has a constant interest rate or a constant rate of return. And here you could think of, well, I mean, this would be a really good investment if every year your money doubled. But your increments could be every 10 years. So you start off with time 0, and then the first 10 years you have whatever, $1, then you get $2. After the next 10 years, 4. After the next 10 years, 8. After another 10 years, 16. So the thing about this, it depends how much money you begin with. If you start with $1, then in 4 increments, let's say 40 years, you get $16. Not so great, but if you start off with $1 million in 40 years, 16 million. The goal would be, if you were investing money, is that you would have your doubling time would be as quick as possible. But okay, that's just one way to look at one application, is that is investing money. This also could be the spreading of the flu. You could think that one person has the flu and then they spread that to 2 people, and those 2 people spread it to 4, and those 4 spread it to 8. So that's another possible way to look at another application. Okay, so this is y equals 2 to the x. Here is the function. Let's then fill in a few other things about this. The domain is all real numbers. The range is the set of, let me put colon again, the set of all y's such that y is strictly greater than 0. You can't get 0. I mean, look, over here, say you have a negative number for x, then you get a fraction. A fraction is only 0 when the numerator is 0. You're not going to get 0. We have a horizontal asymptote. Which is the x-axis. As x approaches negative infinity, that means we go to the left. Y approaches 0. So we go over here, as we go farther and farther left, y gets closer to 0. As x goes to positive infinity, which means x goes to the right, y goes to infinity, which is going up and up. Infinity is not a number. What this means is y gets larger and larger without bound. And the function y equals 2 to the x is increasing. So throughout its domain, it's increasing. Okay, so we'll stop there.